So we've started talking about solving quadratics in 9-3, and we broke it up into 2 different days with graphing, and then we broke it up to finding the square root. So let's do a quick little review. How do we solve a quadratic if we're in the form of ax squared or just ax squared plus c? We just want to solve. Don't make this difficult, just solve. Get the letter by itself. So here we go. First one, and I might move a little quick through this because this is a review. Draw that line down the equal sign. Square root both sides. Don't forget that we can technically have 2 answers when we take the square root. I went through the why behind that in our last video. This would be positive 9 and this would be negative 9. Now we can write this in a little shortcut way as plus minus 9. That means positive and negative 9. I like to write 2 answers out so I know that there's 2 answers. Let's go ahead and look at number 2. Draw a line down the equal sign. I have to get k all by itself, so let's add 196. Whatever we do to one side, we want to do to the other. And we're left with k squared equals 196. Well, that inverse of squared is take that square root. Let's see what k gets when Mrs. Bora puts this in her calculator. 14. So remember, we have positive 14 and we have negative 14. So this would be another 2 solution, crossing the x-axis at 2 places. Number 3. Draw the line. Let's make sure we add 180 to both sides. And if I am going too quick for you, remember I'm limited to 15 minutes on my videos. So this is a review. Feel free to pause it. 5r squared equals 180. Well, before we can take the square root, we got to get rid of that 5 times r squared. The opposite would be divide. Whatever I do to one side, I do to the other. So if I take 180 and I divide that by 5, we get 36. And now the inverse of r squared is taking the square root. So r is positive 6 and negative 6. Let's move on. Now let's talk about how could we solve quadratics in the form of y equals ax squared plus bx. Well, what I want us to notice is that on number 1 especially, we already have it set equal to 0. Okay? The reason behind that is because we're solving for when y is 0. Okay? We're going to start the factoring process here. Okay? I only have an a, which is 1, and I have a b, which is 2n, or the 2 should be my b. So how we can actually solve this one is we can see what do they both have in common. Let's factor. Well, I can factor out, this is taking us back to chapter 8. I can factor an n out. If I factor an n out, I'm left with n plus 2 equals 0. And now in order to solve, we are literally going to take our n and set it equal to 0. So that's one answer. And we're also going to take our n plus 2 and set it equal to 0. And that's our second answer. We got to finish this one. Take away 2. So on these examples, yes, this problem I have 2 answers, 2 solutions. One of them is going to be at 0, 0. Remember my ordered pairs. What you're finding here is when y is 0. So one's going to be at 0 and one's going to be at negative 2, 0. That is where our quadratic is going to be crossing the x-axis. So let's look at number 2. What do you think would be important on number 2 first before I can start factoring? We need to get it equal to 0. So I'm going to move my 5c to the other side. So we have c squared minus 5c equals 0. Now we're ready to factor. Remember when we're factoring here, we want it equal to 0. This is in the form of ax squared plus bx. So what do they both have in common? They have a c. Let's pull that out. I'm left with c minus 5. If I factor out a c, equals 0. We have our two answers. We're going to start with our first one, which is just c equals 0. And we're going to look at our second answer. We're going to set c minus 5 equal to 0. We're going to solve, and there's your second answer, which is just the whole number 5. And remember, that means it's going to cross the x-axis. Our parabola will cross at 0, and it will also cross at 5. Let's look at our last one here. Again, for factoring, we want to make sure it's set equal to 0, so I'm going to move my 6n to the other side. So we have 3n squared minus 6n, and that equals 0. Let's think about our factors here. And these factors, what can we divide out? Well, we're going to take out a 3, and we're also going to be able to divide out an n. They both have a 3 in common and an n. So what do we have left? Well, I have an n. Take away 6 divided by 3 is 2. And this equals 0. Yes, we need to set both of these equal to 0. So we'll start with, we'll set 3n equal to 0. Well, what happens? We divide by 3. We still get n is 0. That's one answer. I'm going to cross my x-axis at the number 0. The parabola will. And we took 3n first. And my second answer is going to be the n minus 2 equal to 0. We're going to add 2 to both sides. We get n equals 2. And that's going to be the second point it will cross. Two solutions for this one. These three examples were two solutions, meaning that parabola is crossing the x-axis at two spots. Let's go ahead and go to the next slide. So how do I solve quadratics if I have it all? If I've got the ax squared plus the bx plus the c, well, we're going to factor, taking us back to chapter 8. Okay, we're gonna factor. Let's start out with changing all our subtraction to add the opposite. So this is 1b squared plus 3b plus negative 4 equals 0. Remember, we want it to be set equal to 0 in order to factor. We start with our a times c, which is negative 4. 1 times negative 4 is negative 4. Let's write out our factors. I could have a negative 1 and a positive 4, or I could have a positive 1 and a negative 4. I could have a positive 2 and a negative 2, and then if we flip that, it's the same thing. Which of these is going to get me, if we add them, a positive 3 for b? That's going to be your negative 1 and your positive 4. So as we factor these, a is 1. A is 1. Let's just go ahead and review. If we didn't have a as 1, we're just going to replace it. So I've got 1b squared. Instead of writing plus 3b, we're putting those factors in, plus negative 1b, plus positive 4b, plus negative 4. Let's do our grouping method. We need to group the first two, and we're going to group the last two. On the first one, what can we divide out? We can take out a b. And what are we left with? We're left with b plus negative 1. Let's look at our last set group. What can we divide out? We can divide out a positive 4. What are we left with? A b plus negative 1. Hopefully you remember the parentheses must be the exact same. So what do we have here? Okay. We have b plus 4 times b plus negative 1, and that equals 0. So that's really a review of factoring. We already know how to do that. Now we're just going to take each one of them equal to 0. So we're going to take our b plus 4 equal to 0, and let's see what we get. Subtract 4, subtract 4. We get negative 4. That is one of our solutions. My parabola is going to cross the x-axis at negative 4. We're going to take our other grouping, b plus negative 1, set it equal to 0. We're going to add 1 to both sides. My second solution is going to be b equals 1. This is a 2 solution. We do have to go through the factoring in order to solve these. We have our ax squared, our bx, and our c. Let's look at one more problem. This is an example where a is not 1, so we needed to review, which I'm glad we did on that last problem, how we go through our grouping method. Plus negative, plus negative. So we're looking at negative 6. What are those factors? I'm going to go ahead and write them out for you, just trying to keep it time-wise, because I know I get 15 minutes and that's it. Negative 5. That's going to be my 1 and my negative 6. Let's go ahead and replace that. So we have 2x squared plus 1x plus negative 6x plus negative 3. And that's all equal to 0. Let's go ahead and group the first two terms and my last two terms. The first two terms I can divide out in x. I'm left with 2x plus 1. The second grouping here I can divide out a negative 3. I'm left with 2x plus 1. So again, these parentheses better be identical or we did something wrong. We have x plus negative 3 times 2x plus 1. Again, that was a review of factoring. What's different? We now set it equal to 0. So we set both of these equal to 0, and we solve. One of my solutions is positive 3, crossing the x-axis at positive 3. And my other solution, it's okay if we have fractions, we're going to end up with 2x equals negative 1. I still have that 2x. We need to divide both sides by 2. So this one is actually a fraction. We're going to cross at negative a half. That's okay. Hopefully what you notice too is probably one of the more common of the 3 types is you'll normally have 2 answers. Not always, but normally. That's it. Review of chapter 8 there as well with factoring and solving these quadratics.